Boolean operators. Okay, Boolean named after, I believe it was the German logistician or logic person, I'll call it, who came up and discovered true or false. Okay, because that is what the data type is. It's really straightforward. Something is true or something is false. That's all a Boolean operator is. Now, we often use it. Is something on? Is something off? Really good thing to use it with. Also, the other thing that it's used with is what we call control structures, and we start with control structures a little bit later, and we use it in those to decide sometimes between different blocks of code that need to be executed. Do we execute A? Do we execute B? Or C or D or something else? Or do we exit? So, really important. We use it to know whether or not we will repeat code. Do we go again and again and again and again? So we use Booleans there. So here's an example of just simple Booleans. Okay, so I'm declaring it is odd. So I've got here, as we've learned, I've got my data type. Okay, and I've got my names, and using the naming convention, lowercase, uppercase, lowercase, uppercase. All right, and here I have initialized them. So I say is odd starts off as false and is positive is true. Now we dive into this thing called the equals operator. Okay, you'll notice there are two equal signs, and hopefully you remember that one. Excuse me. But we often use the equals operator when we're wanting to know if something's true or false, when we're testing the equality between things. We have the assignment operator, which we discussed last time. Okay? The assignment operator, what is on the right-hand side is assigned to what's on the left-hand side. And that's why we get a bit specific in saying assign things, because it's not A equals B, it's what's on the right is assigned to what's on the left. Okay, now when we test for equality in primitive data types, and I've written across it beautifully there, we use two equal signs, and you'll often hear people say equals equals. That's fine. Okay, so an example, x equals y. So what I'm looking for is the value in y and the value in x, are they the same? Okay, and this is going to make a whole lot of sense really shortly. Okay, now when we're testing objects, which we'll talk about later, we can't use that. All right, we'll use what's called the equals method, but we will cover that as we go. All right, so relational operators. Okay, relational operators, we say these things we're evaluating, okay, to true or false, and each operator has exact opposites. So let's have a look at these things. I've got my equals, which is equal to. So I'm checking, is age and 50 the same? Okay, greater than, okay, less than, greater than or equal to, all right, less than or equal to, and not equal to. This is the one that often gets people. The exclamation mark equals means not equal to, okay? Just see I'm moving a little bit out of your picture there, so I fade in and out. Logical operators. We've got three types of logical operators. We have the logical and, okay, both are true. I will come out with you on Friday night, okay? Are we going to place A and at this time? So if we're going to place A and at that time, I'll come out. Otherwise, not. Both must be true. Or only needs one to be true. We go out here or there, I don't care. All right, so or means either of the things must be true. Negation, not. Okay, the opposite of. Pretty straightforward, I would think. So we can start to use these relational operators and the logical operators, to start to make some pretty complex Boolean expression. Now, make sure you're using parentheses, okay, because you want to make sure things get evaluated in the correct order. Otherwise, you could run into some problems. The other thing, which is even probably, well, not more important, but it is important that things are readable, all right? We want to make sure everything we're doing is readable. Some logical operators, okay? And. So in Java, to use and, all right, it's double ampersand. Or is the double pipe. And if you're unfamiliar with the double pipe, that's it there, where my finger is, okay? But if you've never seen it before, okay, it's generally just above the return sign. Logical negation, we've already seen that. We're using the ampersand. And when we use these things, they evaluate to true. So they do what's called, they will return a value of true. So they evaluate to true or false, I should say. So they return a value of true or false. A truth table. Let's have a look at a truth table. A, B, A, B, A and B, A or B, not B. All right, true, 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 false. If you're going, how do we get false there? It's the opposite of that. Okay, so if we say A is true and B is false, all right, A and B will evaluate to false. Remember, both must be true. A or B, well, one or the other is true, so it's true. Not B, well, false, so that means it's true. And we continue on. A is false, B is true, A and B is false. A or B is true and not B is false. All right? And when we set A to false and B to false, A and B is false, A or B is false, and not B is true. Okay, so that's our truth table, and you want to get, I would say, really familiar with the truth tables, because when we start doing A and B, before you debug your programs, because it's not working, I always say, just reverse your logic to see. So here's some examples, okay? So we say here that Boolean red is true, so its value is true if we were to print it out. And this is something, this table here, or this list of things, you can look at and work through it step by step to see how it pans out. Now, Java uses this amazing thing called short circuit evaluation, okay? Because what it does is it minimizes the processing when it comes to Boolean expressions. And what do I mean? Well, only as much as is required gets evaluated. No more. We don't need to. So with logical and, if the first operand is false, the entire expression is false. If you go back to our truth table and look at that. So there's no need to evaluate the second half of the expression, because the first half is false, therefore the whole thing is false. With a logical or, hopefully you're starting to go, oh David, does that mean that if only one needs to be true, if the first one is true, the entire expression is true? The evaluation stops. That's short circuit evaluation, and it's important to understand that Java does short circuit evaluation, because it will help you in understanding and writing logical expressions to take advantage of that. So here's an example of something. X less than 10 and Y greater than 50. Okay, so when X less than 10 is false, we say the entire expression is false. If life equals 42, if that's true, or age is greater than 100, then the whole thing is true. The beauty of short circuit evaluation.